We are Civil Engineering Team 20, and our project was the evaluation of the Keefe Community Center in Hamden, Connecticut. We'll start with a quick team introduction. Going from left to right, we have Eric Vasquez, Nick Fury, Dylan Leitao, Mitchell Bluestein, and Chris Cavoto. The goal of our project was to evaluate the Keefe Community Center for a wide range of deficiencies. Most importantly, the town of Hamden would like to know what the maximum permissible snow load is on the roof structures. They would also like the wind loads to be calculated, as well as making sure the building's foundation is structurally sound. Next, we were tasked with determining whether the building may be in danger of severe flooding, and finally, the necessary steps to transform the community center into an emergency shelter in the event of a natural disaster. The main goal was to determine the maximum permissible snow load on the main, daycare, senior center, and foyer roofs. In order to complete these calculations, we followed equations from ASCE 716 along with the CT State Building Code. It was important to consider the additional drifting loads on all roofs besides the main roof since it was the tallest.
The roof structure for all the buildings, besides the main one, was made up of K-series joists, and they were found to hold around 5 feet of snow safely. The main roof was made up of 2x10 lumber of an unknown material. Due to the region we're in, an educated guess of Douglas fir was made as to the material for the roof. With the tributary area of the joist being known, the max uniform snow load was found to be around 3 feet. So snowstorms around 2.5 feet is when the roof should be shoveled for peace of mind. If the roof structure was to get an overhaul, an alternative roof structure to handle the extreme snowstorms was designed. Each roof would be made up of a mix of K-series joists spaced at 4 feet. Due to cost of materials, though, it does not make sense to replace the roofs.
The wind loads for the building were evaluated using ASCE 716. 2 scenarios were accounted for: tornado winds and the 3-second gust, which was found using the map shown on screen. Before we visited the building, there were some concerns about if the building had foundational damage. Some methods, such as slab jacking, shown on the left, or micropiling, shown on the right, were researched and compared. When we actually visited the building, we found no obvious signs of foundational damage. It was determined after this that we would not take more thorough steps to determine if there was any foundational damage, as we saw no clear signs of any damage.
To determine if the Keefe Center was under jeopardy of flooding, we looked at the following storm data. The chart depicts the estimated average recurrence interval, AVI, in years, compared to the duration of the storm. This predicts the average rainfall of the storm would have in inches. Data was averaged with the higher and lower bound intervals with 90% confidence. The graph to the right shows a more visual representation of the data with the precipitation versus AVI graph plot lines based off of the duration of the storm. To make the data more applicable and have a better understanding of what the data means, we can look at the figure here. The map shows the Keefe Center is not in jeopardy of flooding, as can be seen by the blue area in the map, which depicts the area without base flood elevation. Base flood being the 1% annual chance of flooding or a 100-year storm. So in an event of a 100-year storm, there is a chance of flooding in these areas.
The goal of this part of the project was to transform the Keefe Center into an emergency mass sheltering location. The Keefe Community Center has the potential to become a verified shelter location. To meet the standards, the building's structural deficiencies have been assessed and all related engineering logistics have been considered. In order to successfully create an emergency shelter from the Keefe Center, the following criteria must be met. Emergency management planning is implemented through our communication with local officials at the Town of Hamden Fire Department. ADA regulations cover the criteria in the diagram shown. These ensure there are accessible routes throughout the shelter and also that there are sufficient restrooms and eating areas within the building. Finally, an emergency power supply must be installed in the event an extreme storm takes out all power. To complete the implementation of this plan, an electrical contractor would be sent out to the site to assess the power output and accurately size the generator needed. To meet regulations, the center would need to provide 3 additional portable bathrooms and 6 portable shower facilities. And finally, we must finalize plans with local emergency management officials.
Overall, the Keefe Community Center is structurally sound, doesn't have any pressing concerns, and the steps are laid out for what is necessary to transform the community center into an emergency shelter. This is the end of our presentation. Thank you for listening.